everyone. Welcome to Kubernetes and MLOps for scalable and reproducible generative AI workflows. A very exciting topic. I'm at least excited. I hope you all are as well. So I'm Annie Talvasto. A bit about me in a couple of slides, but first, I think everyone would love to probably know what is this session about actually, and what are we going to be talking about in this 20 to 25 minute time frame here. So let's get talking about that. So what will this session be about? So this is going to be an overview or an introduction, depending on how you see it, into MLOps and AI on Kubernetes specifically. And obviously you can use a lot of these tips for some other things as well, but that's going to be the focus. Overview, introduction things. Hopefully, usually people have either a more of a Kubernetes background, or they have DevOps background, or they have data or AI or ML background, or you're completely new to the topic. All of this is totally fine. I hope everyone gets to learn something new today, but it's a nice overview of all the things that are happening right now, because you might have heard that there's a bit of an AI buzz. A bit of an AI hype going on. So particularly for that, cutting through that hype and understanding what do these things actually mean, I hope this session is helpful for everyone. Great. So let's kick us off. So I am Annie, as promised. There was a bit about me. So I'm Annie Talvasto. I'm a CTO and founder, and I'm a CNCF ambassador as well as an Azure and AI platform MVP. So those two essentially mean that I just love sharing my knowledge around all of these topics and sharing that in, let's say, conferences, videos, all of these type of things. And very excited about cloud native AI, ML in general. So very excited to be talking to you here as well today because of that. Now, I'm also a Kubernetes and CNCF meetup co-organizer since 2017. So I've been doing that for a few years already, very much into open source communities in general. I'm also a startup coach. I coach early stage startups through a couple of accelerator programs. And then I've created a TechCraft show, which is a YouTube show where I play Minecraft with tech guests. And then obviously Minecraft playing might not be the top notch, but that's part of the fun. But obviously the guests are top notch in their fields and technology. So that's a fun show for sure. Now, moving on to the actual content of today. So we have a packed agenda to go through in just a bit over 20 minutes. So you're in for a ride for sure. So we have the introduction to kick us off, which is already on the way here right now. So that's really nice. We're moving fast. And then we have some definitions, because we have some really important definitions to cover. And if you hear my dog barking in the background, that's just because he is on an endless blood feud with the mailman. So if he hears him coming, he's going to bark, but we'll ignore that. It's all good. So definitions. So AI, ML, MLOps, all of these things are very much buzzwords. There's so much hype around them. It's really important to actually understand what are they and why do they matter, and how are they most importantly in relation to each other. So that's exactly what we'll be focusing on today. And then we're going to talk about why is AI or ML, so machine learning, different from traditional quote-unquote engineering. And then we're going to talk a bit about Kubernetes and MLOps as well, and how do they fit together. Then going to be, spoiler alert, a bit about Kubeflow in terms of how Kubernetes and MLOps works together as well. And then we have some best practices, considerations, and then we have some wrap-up and resources as well. So that's the agenda for today. And we're going to be going through that right now. So, and just to make it a tiny bit more fun, we have this treasure map, a pirate map, you could say, where we're going to be walking through our agenda with it. So you can see there's, the kickoff with the pirate ship, and then we move on to different locations. There's the skull location, obviously the scariest part of it all. And then at the end is the treasure, which in our case is scalable and reproducible generative AI workflows, which obviously is the goal of today. So that's where we'll hit it through all of these mountains and whatnot. Now, we have our companion, the robot, that's going to be moving with us through the agenda. So that's going to be heading off here today, right now. And we go to our first step, which is the definitions. So now I mentioned already that these are particularly in such an industry or a moment in time where there's so much talk about things. it's important to actually know why are we talking about them and what are we talking about precisely, because these things get muddled as well. And obviously, since AI and ML are moving forward in quite big leaps, there's a lot of changes happening even on a monthly or weekly basis. The definitions might obviously kind of shift, particularly in the way that we talk about them colloquially or within our day-to-day conversations. So it's nice to kind of, define some things as well. So AI, or artificial intelligence, refers to the simulation of human intelligence in machines that are programmed to think and learn like humans. So how does it differ from machine learning as well? So machine learning is the use and development of computer systems that are able to learn and adapt without following explicit instructions by using algorithms and statistical models and so forth. So the learning and the adapting is one of the biggest differences there compared to AI. Data science, on the other hand, is a multidisciplinary field that uses various techniques, algorithms, processes, and systems to extract insights and knowledge from data. So obviously goes very much hand in hand with machine learning because you need the data to be able to learn and adapt. So that's kind of, how these two correlate to each other. And then we have DevOps, which is derived from development and operations, which is a cultural and technical framework that like mashes up software development with IT operations best practices. Now, the important part in this part is MLOps and what's the definition or difference between DevOps and MLOps. So MLOps is machine learning operations, and it's a set of practices and principles that combine machine learning and the practices of DevOps. It kind of makes sense, doesn't it? DevOps, MLOps, like you can hear it, you can see it. But I think quite often, particularly since the industry of ML/AI has been moving on so fast, it's actually quite interesting to remember that a lot of the learnings that we have learned and we can take from the DevOps side, we can apply to the MLOps side, both in terms of like, okay, how will the trajectory of the field likely, like what kind of learnings are on the horizon as well as obviously actual practical, Axe might work in DevOps, and then you think like, okay, let's try Axe in MLOps. There's differences, and obviously that's going to be the next portion of the session, but I think we can all kind of use a lot of our existing knowledge if you know DevOps things already. And if you don't, there's a wealth of knowledge that you can Google and learn about in regards to DevOps first or within your journey of learning more about MLOps as well. Now, that's about that. Done with the definitions part there. So then we're going to be moving on to the mountains, as you can see with our little robot. So why is AI and ML different from traditional engineering then? That's the question next. So what does it actually mean to go from research to production for a AI app, ML, and so forth? So I think quite often there's a perception of people that in AI development or ML development lifecycle, the model creation is the difficult, the time-consuming part. But actually, it's the opposite way. So usually, sometimes models might even take just a couple of weeks to develop. It could be one person, a small team or whatnot, developing it locally, just, working on it. And then they need to obviously get things to production for the model to start producing value. Now, this is exactly where the tricky part starts. So that part, the model development might take just a couple of weeks. And then when we move to the production part, months. It can take months if it never ever makes it there. So there's different numbers always floating around. What is the number of models that never make it to production? But usually it's about 70 or even 80% that people quote. So you can kind of, take a moment to think like, 70 or 8 to 80% of the models never make it to production, aka never actually provide any value that they were created to provide. So that's something that I think really makes you understand that how much actually focus is there needed to the production side in the ML and AI field. So production is actually the big bottleneck rather than the model development side. So there's a lot of focus there that we can kind of, think about. So that's why from research to production is actually quite a treacherous, walk in a lot of ways. And why is that? Well, next up, we're going to find out how and why is ML and AI going to production with them so much trickier than actually doing just plain old quote unquote traditional software engineering in that way. So it is due to a couple of different reasons. So for example, it is because the models are data centric in nature. So all of ML and AI are this way. So the quality and the quantity of data significantly impacts the performance of the models. So this means that ML and AI engineers need to focus on data collection, pre-processing, and feature engineering, which are not as central in traditional engineering. And this is the big one, because data centric really truly means like if the data that goes in is bad, the results will be bad no matter how great the model itself is. So which is why data science is such an important field within this area as well. So that is a big one. Then there's also model complexity. So in regular engineering, systems are typically designed and built according to well-established principles and specifications. And in contrast, ML and AI models are complex and their behavior is learned from data. That's the learning from data part that I mentioned in the definition as well. So engineers must experiment with various model architectures, hyperparameters, and training data to optimize performance. So that's exactly where you get to, and you're dealing with a lot of data coming in, you're dealing with complexity of the models and the learning aspect. Oh, it gets a lot because iterative development comes from here as well. So ML and AI development is often highly iterative. So engineers continually experiment, fine-tune models, and retrain them to achieve desired outcomes. So traditional engineering projects tend to have a bit more predictable and linear development processes. So because of the learning aspect needed and adapting and the iterativeness of it, it becomes quite a bit trickier. Now, all of that data leads to scale. So scalability usually have a lot of data coming in. So ML solutions often require scalable infrastructure to handle large data sets and computational demands. So this might involve distributed frameworks like Spark or GPU clusters or cloud-based resources. So traditional engineering might not have the same scalability demands as a whole. Now, monitoring and adaptation is super important as well. I mentioned a lot of data coming in, iterativeness. So obviously you need to monitor and adapt within your cycles as well. So ML and AI systems require ongoing monitoring to detect issues like model drift, data quality changes, or shifts in user behavior. And engineers must build systems that can adapt to these changes in real time. So whereas regular engineering might not have that many needs essentially as well. Now, testing and validation is important as well. So in regular engineering, testing and validation can be based on established standards or specifications. In ML/AI engineering, testing often involves evaluating model performance against specific metrics, and the validation might actually require some domain-specific expertise. So, for example, if you are evaluating healthcare information, you do need probably someone who is actually deep in the healthcare realm to actually validate, is this the correct response or not? So there might not even be clear-cut pass or fail criteria. And explainability and bias is important as well. So understanding why an AI model makes a particular decision is crucial, especially within critical applications like healthcare, as I mentioned there right now, or finance. These things are very important to humans, and there's real-life repercussions if you do things. So you need to be able to address explainability and bias, which are concerns in traditional engineering, but I think we can all agree that they're very much of concern in ML and AI space. Now, rapid advancements probably aren't a new thing to anyone who's in the tech space. We're used to having, a lot of information pushed to us, but particularly ML and AI right now is rapidly evolving with new techniques, libraries, and tools emerging constantly and regularly. So AI engineers must stay up to date with the latest developments because there's so much stuff going on. And also collaboration, as once again, always a big part of DevOps as well it is part of MLOps as well. So ML and AI projects often require close collaboration between data scientists, software engineers, domain experts, and infrastructure engineers. So just as I mentioned before, for that testing phase and understanding validation, you need to probably collaborate with a lot of different domain experts, for example. So actually collaborating with all of those big teams requires a little bit more careful thought. And with all of this complexity, data-centric iterativeness, deployment challenges are quite real. So deploying ML and AI models into production requires special considerations. So engineers must really ensure that models are served efficiently, can handle real-time requests, and integrate with existing systems, which is, always difficult across everything as well. And cost is also a big one. So even though we would always, I think, as technology professionals might want to go with the latest and greatest and go crazy and nuts with it, you don't want to go bankrupt because of your new ML and AI applications either. And because of all of the data centricity, iterative testing, all of these things, the AI and ML applications can be quite costly. So you do really need to keep that costs in mind while maintaining performance and making sure all of these other things that I mentioned stay on top of it. So no wonder there's a lot to do. Now, if you are thinking about, what would be the actual some of the tooling that I could use for a lot of these different stages and all of these different phases, I like to give an example here that you can actually dive deeper with an hour-long resource as well on your own. So I have the link to the video by the end of this session, but here is an example of a basic MLOps flow. Now, I give this one because, again, there's an hour-long video diving deeper into just these specific ones if you want to learn more. But I think the most important learning here is that instead of, thinking that, I really do need to, like here in week 0, use PyTorch Lightning or something, no, that is not required or mandatory per se, but you have to have all of these steps considered. So you need to think about the where are you using your containers? Where is your, are you using the Lambda? Are you using Kubernetes? Are you using AWS for this or Elasticsearch that or Azure for that, Docker? So there's a lot of different phases from ML development to training and operationalization, model deployment, prediction serving, continuous monitoring. And I am focused on Kubernetes. So for me, for example, instead of AWS Lambda, I would probably go in this image with Kubernetes. But again, everyone has their own focuses, and I'll give the link to this resource particularly in the end. Now, a bit more about Kubernetes and MLOps in general. So, moving here to the jungle by the sea. So, why Kubernetes and MLOps? Why am I talking about these two? So, if you're familiar with Kubernetes, a lot of the stuff that I mentioned before around why is ML and AI development different from regular engineering, you probably started to, connect the dots in your head. Well, Kubernetes is really, really great base, a layer to build AI applications on top of it because of the portability. Again, connects with a lot of the points that I said before. So Kubernetes provides a consistent and portable platform for running machine learning workloads. And ML models and their dependencies can be made containerized using Docker, making them highly portable across different Kubernetes clusters. And you can develop and test ML models in one environment seamlessly and deploy them into another one without worrying about your environment-specific resources. Customizability, great part about Kubernetes as well. So you can really tailor your Kubernetes to your infrastructure, to your specific ML needs. So this leads to that you can have customization, enables fine-grained control over resource allocation, ensuring that ML models receive the appropriate amount of GPU and CPU resources. And you can set up custom environments and configurations for different stages. Kubernetes, if it's known for one thing, it's known for scale and performance. So perfect match with the ML and AI scale needs that I mentioned before as well. And Kubernetes horizontal scaling allows ML workloads to automatically adapt to varying levels of demand, maintaining responsiveness, and efficient resource management minimizes research contention, ensuring that models receive the necessary compute resources to perform optimally at all times. Now, consistency is another good thing about Kubernetes. So Kubernetes enforces consistency by providing a standardized and consistent environment for running ML workloads, which reduces the risk of disparities between development and production environments and provides a consistent platform for model training, serving, and monitoring and improving operational stability. Now, microservices is another one. So Kubernetes allows you to break down ML applications into smaller and independently deployable components, which then provide you with modularity, flexibility in ML workflows, making it easier to update and scale individual components. And you can orchestrate microservices as building blocks, making everything a tiny bit easier for you. Composability is the last one on my list on Kubernetes plus MLOps, mixing up together. So Kubernetes allows you to compose and orchestrate ML components and services into end-to-end ML workflows. So you can define, share, and reproduce ML workflows as code and enhancing collaboration and efficiency, and integrate various components like data preprocessing, model training, and model deployment into a cohesive pipeline altogether. So that's the little snippet on Kubernetes and MLOps together. And now moving to Kubeflow, which is an essential and extension to Kubernetes that you can use, and moving there to the jungle properly. Now there's a lot of host of different other resources that you can tap into. So you can, on Kubeflow, I'll be talking a bit more from CNCF or open source world. There's OpenTelemetry, Kubernetes superpowers with K83P as SPG, Prometheus, Argo, a bit of a tongue twister there for me there, but a lot of good tooling that you can check out on your own as well and dive deeper into. And obviously Prometheus is an oldie but a goodie because again, there's so much, basic monitoring needs with ML&A applications. So Prometheus, for example, works really nicely there. Now, a bit more about Kubeflow, so machine learning toolkit for Kubernetes. And Kubeflow is a CNCF project, and it is an open source platform that's designed to make it easier to deploy, manage, and scale machine learning ML workloads on Kubernetes. And it provides a set of tools, frameworks, and best practices to streamline the development and deployment of machine learning models in Kubernetes environments specifically. So what does it actually then do, and what does it provide? So it provides end-to-end ML workflow. So it from data preprocessing and model training, the deployment and monitoring. So you can reduce the complexity of managing different tools, for example. It provides scalability and resource management. So you can leverage Kubernetes orchestration capabilities really easily. It gives you reproducibility and collaboration. So encourages the best practices of Kubernetes by capturing metadata, environment details, and code versions associated with each experiment as well. So there's a lot of benefits there. And now the same as with across all of CNCF projects in Kubeflow, if you're doing something really small and you don't require the scale of these projects, then you might not need these toolings. But if you're doing something on a bit bigger scale, this is, running a hobby projects, these might be relevant tooling for you to try out. Then if you're hearing the New York City background noise, I'm based here and there's always some ambulances going on, but I hope it doesn't translate through the microphone to everyone. But anyhow, Kubeflow, you have notebooks, model training, fairing, model serving, miscellaneous, pipelines, all of these things you can tap into. Now, before Kubeflow, it looks like this. You have experimental phase, identify problem and collect and analyze data, production phase. Then you can tap into all of these tooling, so PyTorch, TensorFlow, Jupyter Notebooks, all of these within your workflows. Now, if you're looking for a great example on how things look like in practice, KubeCon had one keynote session from Shell, so fully automated pipelines, how they actually use Kubeflow and how their fully automated pipelines speed up the model training time and how they helped both cost, so they managed cost with Kubeflow, as well as they helped a lot specifically with self-service. So when you have a lot of like data scientists, for example, or different people building models using Kubernetes, you don't want them to actually, needing to learn all the ins and outs of Kubernetes. And with Kubeflow, Shell was able to take the self-service onboarding from months to just essentially minutes, which is obviously a great benefit. So you can check that out. I have a link to that later as well. So now we are nearing the end and we're going to go quickly to the mountain. Best practices rapid fire because we've been covering a lot of these already. MLOps loves DevOps. Highly recommend tapping to both of their knowledge together, understanding the bottlenecks, so figure out where in your production or your model development, where are the issues and how to kind of go at them and try to fix them in there. Up-level your skills. So if you're coming from a data world, you might need to learn a bit more about infrastructure, Kubernetes, cloud. If you're coming from DevOps world, probably you need to brush up a bit on even a bit of ML, AI, math, one of some of these things. It's all in the data. I talked about that already. It's all in the data as well. And if you are new to DevOps best practices, highly recommend checking them out. Here's just a couple of them, from automation to CI/CD and whatnot. So highly recommend checking those out. Then we have some considerations, which is the school area, because it's always the treacherous part. So ethical considerations, I think, are highly important. I'm not going to dive here today because this is just a 20-minute session, but all of these things, fairness, bias, transparency, privacy, accountability, so important in the ML and AI space. So you really do have to focus on that more than traditional engineering. Not that you don't have to in the other one, but it's important here particularly. Now, there's a lot of good Learn More resources here, and you can find all of my links and slides from my GitHub. So if you don't get some of these links right now, don't worry, you can always go there and find them there. So the keynote, Machine Learning on Kubernetes Made Easy with Kubeflow, is the self resource that I mentioned, end-to-end MLOps basics from MLOps Meetup, which is from the MLOps community YouTube channel, is there as well. And also, if you want just more snippets of terminals, understanding how to, click through practical MLOps from O'Reilly and Noah and Alfredo, great resource to tap into there. Now we are pretty much at the end of the road. As you can see, our little robot has even finished the school portion, and we're going to go to the treasure part. So here we are. Our robot is happy. We have our treasure, the scalable and reproducible generative AI workflow. So we're doing well, and we are nicely here in the end. I hope everyone learned something new, and I love browsing through AI memes and MLOps memes. So here is a collection of some of my favorite. Thank you everyone for listening. As I said, I hope everyone learned something new, and I will be in the Q&A portion helping and answering all of your questions there. Thank you so much.